Hi, Mick McQuaid here to talk to you about joining tables together, which is a very important activity in using SQL. So the normalization process divides the data up into separate tables to prevent anomalies. And as a result, we have the situation where most real-world activities require data from more than one table. So we have to join them together using the SQL join clause. And we can use several join clauses in one select statement to join several tables together, which is often needed. And there are several different kinds of join clauses, which are illustrated by the Venn diagram on the following frame. So this is a very commonly used diagram, and it has a typo in it. Every place where it says table space A, it should just be table A without a space in there. So the name of the table is table A, and the alias for the table is the letter A. Okay, so I don't know why that is, but there are a lot of copies of this in different versions with different typefaces and so on, and they all seem to have the same typo in them. In any event, what we see here in the center is the most common kind of join, the inner join. This is usually what you want when you join, and as a result, the inner join is the default. So if you don't put a keyword like inner or left or full outer, you just say join, select from table, join table, you'll get an inner join. And the inner join selects rows that are present in both tables. And this will become more clear later, but I just want to give you this diagram to refer back to after you've learned more about this. Now there's also a left and right join, and we've experienced a left join in the flights database where we wanted the airport names for just the airports that were destinations for flights. We didn't want all the other airports that weren't destinations for flights. And of course, left join has its mirror companion, right join. I don't really know why these are both necessary. You can just substitute one for the other and make them both left joins or both right joins. But maybe it's easier to form a mental model of a right join sometimes and a left join sometimes. So maybe that's why that's allowed in SQL. And then there are also left and right joins that omit the inner part. If the key is null, then in this case, if the A key is null, all of the A records are, all of the matching A records are not used, and this returns a subset of B. Now these two at the bottom are rarely used, and I don't want you using them in this class. A full outer join returns the union of the two tables, and consequently you can run into a situation where it returns multiples of the two tables. So I have an example in another class I teach where the students have to join two tables that are each several gigabytes in size. And the resulting join should be an inner join. But some students panicked because it turned out that later that we found out that one of the tables had all caps and the other table had mixed case. So when they did an inner join, no records were returned. So they got desperate, panicked, and did a full outer join, and they got records returned, but there were so many records that they quickly ran out of memory. And so don't do that kind of thing. If you're not getting any records when you do an inner join, explore the possible reasons for that instead of defaulting to doing a full outer join. It's rare that you need a full outer join, and of course you can do a full outer join with null keys, so that you just get the parts of the two tables that have nothing in common. Okay, now here's an optionals frame. Database classes sometimes make you memorize De Morgan's laws. I don't make you memorize De Morgan's laws. Is to understand the logic of joins. So De Morgan's laws, and again, this is optional. The negation of A and B is the same as not A or not B, and the negation of A or B is the same as not A and not B. So people who studied new math in grade school may already be familiar with a bit of set theory and may be comfortable with this kind of idea. And you can visit, for example, this Wikipedia page to understand the logic of joins and to view more Venn diagrams. I just want to say that that's not been necessary in practice in my case. The Venn diagrams can be helpful if you're having problems with your joins, but understanding the underlying set theory has not been necessary in my experience. So that's why I say this is optional. It's very commonly taught in database classes, so I expose you to it, but I don't require you to memorize it as some do. Okay, so now I would like to get out of this slideshow and do some actual join clauses. So we're going to use the scratchpad.sql file in the SQLite samples directory. And you can scroll down to line 65 or search for the text using joins. So that's the end of this slideshow, but I'm now going to get into, oops, I'm in the wrong place. Let me get into, I'm still in the wrong place. Okay, here we go. So I'm in the SQLite examples directory in both of these window panes. So in this, because this one is outlined in green, this is the one that is in focus. And in this one, I'm going to open the Scratchpad file in a text editor. And I'd like you to do that same thing. And I'm going to go down to line 65. So I'm on line 65 in there. And then in the other window, I want you to start SQLite 3. And it's important that you're in the same directory in both of these cases. Okay, so I'm going to run some dot commands, all these dot commands first. These are commented out because they're not SQL commands. In fact, I made a mistake in this file. I'll probably update this file because I left some of the dot commands exposed, and they shouldn't be. Okay, the first one is going to be to remove the library.db command. I mean, the library.db file. And initially it's asking me where I want to paste this. I'm using a special cut and paste tool to cut and paste from the, or copy and paste rather, from the scratchpad.sql file into the SQLite window. Now I'm going to open this file, which is now empty. It now doesn't exist. I've removed it. So now I'm going to say open library.db. So I've now opened, so now if I say tables, I'll go down here and say tables, it's going to return nothing. So I'm going to say read library.sql, which is the same thing as using the SQLite 3 library.db > library.sql command at the terminal window. I need a better solution for this, I think. Okay, so now I have a bunch of tables, and I can check the schema of the tables. So I'm going to check the schema of books. And you can see that it has a book ID, a title, a publisher ID, and a year. And then I'm going to check the schema for publishers. It has a publisher ID and a publisher name. And I'm not going to change the mode to column here. In fact, I'm going to delete this line because I like the new default. Okay, so I've selected books, title, and publisher's publisher from books and publishers on publisher ID equals publisher ID in the respective tables. And so I get the title of a book and its publisher. And I don't know what most of these books are. I'm assuming these are real books because I noticed an author that I recognized, and I do recognize some of the publisher names. But I've never heard of these books. They're, I think, favorite books of a prior instructor of this course. Okay, now I'm going to do the same thing, except I'm going to order them by title. So notice that this is arbitrarily ordered, but I'd like to sort them by title. So I'm going to use the order by clause here. And we can see that they've done a poor practice here of including the instead of saying Awakened Kingdom, comma, the. They've said the Awakened Kingdom. So we have a bunch of titles, and I'll bet the same thing is true of A here at the beginning. Yeah, so yeah. Okay, so, but we've ordered them by title. And I can also group them by publishers and then order them by count descending. So what I'm going to do here is only return the publisher and the count of the publisher. So that's what you've got. And I've grouped them by publishers and ordered by count descending. And that group by means that I'm counting the number of books published by that publisher. So Tor Books has published 12 of these books, Orbit Books has published 6 of them, and so on. And I did this in descending. If I did it in ascending order, I would get the 1s at the top and the 12s at the bottom. Now I'm doing the count in a slightly different way. I'm putting some space before it. Now this is wrong. What did I do wrong here? This shouldn't have printed the single quote marks. I'm not sure why that happened. It looks right to the function call looks right to me, but it should have just introduced spaces. So this means to print it in the number in 5 spaces and to print the number as an integer or decimal as what the D is for. And it should be the count of publisher.publishers. So it should be the same information, but with space in front of it. And I'll have to investigate afterward why it's got the single quote marks around it. Okay, now I'm going to select the publishers that have little in the name somewhere. I'm going to do this in 2 phases. I'm first going to just do this one. And you can see that little accidentally has a quote mark in the name. So I'm going to update publishers and change it so that it doesn't have a quote mark in the name. And now if I do this first query again, I get this. Okay, and then there's another mistake here. The for Kush is spelled Quest Focush. So I'm going to correct that mistake using the update. Oops. So that's what I've got right now. So now I'm going to change it. Wait, that doesn't make sense. There we go. That makes more sense. So now, if I do this one, I get nothing. And if instead I do, let's add another query down here. It's spelled correctly. Okay, so here are joins part 2. We're going to do library again. Tables, schema, authors, alter book books. Okay, so if we take a look at the tables, we see that one of the tables has kind of a silly name. It's called book books, and it is an associative table. Let's look at what's in it. So I'm going to say and of course I already know what's in it, but I'm just doing this for pedagogical purposes. So what we've got in it is the book format and the book ID, the book format ID and the book ID. So this is wrong too. This should say the book format ID should be the primary key. I've probably tampered with this before for academic purposes, but let's do it. Let's change the name of book books to book format because that's a more descriptive name. So can I do that? Here, let's see. Now if I say tables, yeah, that worked. So now I'm going to do the format of books. So I'm getting the title and format and joining them on format ID rather than book format ID, which is just a primary key in the book format table. And it looks like I've only got about 3 formats here. Here's one that you're not probably going to do because it doesn't look great. So instead, we're going to do this. So instead of Elizabeth and then a big space and Bear, Karen Memory. And by the way, this is why I know that this is a real book. This is actually the only book in the entire collection that I know is a real book, but I'm assuming that the others are as well. So we selected the author first name and the author last name as 2 separate columns. We're going to use the concat function, which concatenates columns together, and we're going to use the first name function followed by a space followed by the last name. And now this looks much better. We have the first name followed by the last name, and we can sort it on last name. And we have sorted it on last name, despite the fact that we're showing the first name first. It's sorted on last name. We can sort it on any column in the tables. Here is a much more elaborate, let's see what this is. So we've printed the row number here, and again we have this I wonder if that's an artifact of the mode command. That could be part of the .mode command that's doing that. I don't know if we change modes we'll get that same result. I'll check on that later. But in any event, we've got a row number, and we're calling that just number. And we're doing the same concatenation, and we're joining and we're ordering by we're joining first by the author's last name and then second by the book's title. So notice that for Tamsin Muir we have 2 books and they're now in alphabetical order, and for this one we have a number of them, 4 of them, and they're in alphabetical order. So we can order by as many columns as we want if we have nested things. Did I just do this one or this one? What is going on with this one? I think there's a mistake in this one. I use the syntax highlighting to partly for clarity, but also partly to see if there's a problem. And notice that this isn't syntax highlighted. This one is, but this one isn't. So that means that somewhere there was a syntax problem. Let's just run this one and see what happens. And I don't see an obvious problem. Sometimes that syntax highlighting thing just gives spurious results. Okay, now I'm going to show you a couple of queries that are not required. So here are queries that were done by someone. Okay, the first couple are done by someone else. So we've got oh, I'm in the wrong table. So I've got to do this first. I mean, I'm in the wrong database. Wow, this is too big. Let's see what happens if it's still too big. So here is a good candidate for the list format because it's so big. So I'm going to change the mode. Is it list or line? I think it's line, actually. Yeah, line is the mode. So this puts everything on one line, every column on one line. So it allows me to, obviously the output is very long if we do it this way, but I've limited it to 10 outputs, so that's good. Okay, so this shows the most purchased tracks of 2013. So these are the top 10 most purchased tracks of 2013. So are they sorted? Did I select count? Where is count? See, I said select as count, but I'm not seeing count here. Oh, the count is down here. This is completely wrong. This can't be right. So you got to check your work. So this was done by somebody else. And I didn't check it, I just included it. It was in this GitHub thing. Maybe it's intended that you You're not telling me, okay, so first I got to do a sanity check on this. So now what I want to do is a query similar to this. See, I still need all of these. Let's do this. Let's do it for all time, because maybe 2013 is just not a good year to do it on. Okay. But we still just get 2. So people aren't buying. I thought people buy individual tracks, but people are not buying individual. Oh. People must be buying albums. Let's try this. Let's forget about tracks. What could be the other invoice items? Let's see what, okay, I'm gonna do this again. It's valuable to keep an audit trail of what you're doing so you don't just keep repeating the same thing over and over again or lose track of the things that you've tried already. So what I want to do is get rid of tracks, and I want to count the invoice items. What's in invoice items? Let's find out what's in invoice items first. Ooh, we didn't do anything with quantity, did we? Let's also select star from invoices. See what's in there. Oops. And well, we've already selected in a previous lifetime, we selected the count of the total from invoices. Let's just do that again. We're going to have to do a join here because we don't know what. What am I going to group by? What if I group by invoice ID? This is really looking like a mess, so let me do the proper thing here. So do you see the error I made there? So I made another error here. And yet another error. So I could, make a new one for each one of these that I do, but I usually only try to do no, that didn't work. That's just telling me how many invoices I've got. Or it's telling me the total amount of money I made, which is not much. Not worth doing all this SQL over $2,200. That was a mistake. What am I doing wrong here? I don't know. I'm going to skip this for now and come back to it later and give you an addendum. So here are some examples of getting an LLM to write something. Now these are old examples. I'm sure that an LLM will do better now, and in fact I'm going to try it. I fed the database schema. They both hallucinated column names anyway and failed. Following are two correct ones that I wrote manually. So am I in Chinook? Oh, I'm in the wrong mode here. Let me change them. Can I do this? I don't know if this is legal. But the default mode is a pain to unknown mode. Okay. I'm going to have to say mode box. That's the best I can do. The actual mode is like called Q, I think called Q box, but it has some additional stuff. Well, this is this is not good. So what we want is probably to add this. Let's see what happens if we add this. Maybe I have to say it before. Yeah, I do have to say it before. Okay. So I don't know how I made that error, but I did. And this tells us the same thing except with the numbers. And the total gives us the same effect as the distinct did here. Let's see. Manually total the counts. Two more examples. There are other aggregate functions. Okay, well, group concat name. So this is all the track names on an album using the group concat function. So we wouldn't put this is now non-atomic, so we wouldn't put this back into the database. But we might want it in a specialized data warehouse. Common table expression. These I'm not going to require you to do. This uses the with statement and gives us the stuff. Oh, that's what I should have done before, but it's not required for this class to do with. So I just show you that so you know what kinds of things are available. You're not going to be required to use those in this class in anything that you do. So you define a temporary table that you can then query, and this is from the SQLite tutorial.net page. Let's just see if So I tried this with 2 LLMs just for fun. Let's get out of this. And we're going to get into Claude Code. And I'm going to say using the Chinook DB file and the Chinook.sql file, write an SQL query that tells what media types customers purchased. And where those previous ones failed, I think Claude will succeed. These are getting better all the time. Let's see. Why is it creating? Wait a second. Oh, schema. Oh, okay, I got it. There's something wrong here. See, I tried to go down to line 2 to say, go ahead with all of these. Okay, so let's see what happens if I use this. Oh, it wants to run it itself. Okay. Oh, and it explained, so it did it and explained it. But I want the distinct ones. So I guess I didn't give the right instructions. So this will solve that problem, probably. And notice it's not hallucinating any oh wow, and it gives us a little blurb about what's going on. Okay, so let's run this query ourselves. So I'm just going to copy this. Where is the okay, so these I wrote manually. So let's go down here and say at a later time, oops, let me format this better. It's always a good idea, if you can, to document which model you used, not just the shell. Okay, and as usual, when I paste from Claude, it adds a lot of substitute. It adds a lot of extra white space at the end. All this white space gets copied for some reason. I don't know why. So I'm going to now get back into... oh, I could have sorted it too. That's a nice idea. All right, but I'm going to quit out of this for now. Get back into SQLite 3. And I'm going to first say... and this whole exercise is really just to show you how far... what did I do wrong here? Oh, it worked. Okay, never mind. Okay, let's run this query and see what we get. And this looks fine to me. It's different from what we produced up here two paragraphs ago. And it's different in the sense that it doesn't give a separate line for each combo. It puts the various media types in the same row. So what does it call that? Media types purchased. Okay, and I could sort these by, if I go back into Claude, let's get out of this and get back into Claude and say resume. I want to just continue the I want to continue that one. And that was what it was offering to do next, I think. But we lost that. It was on this line where I overwrote it with the word exit. So it's not going to look exactly the same because it's going to have to put the media types on different lines, I assume. Okay, and see, this is very long to figure out. Distinct media types are ordered by purchase frequency. Is that what I meant? That's not exactly what I meant, I think. Let's see what it does. Okay, let's try this. Oh, you know what? I'm going to move this down here. What did I do? I just did something wrong here. And I'm not sure what. I want to get rid of all of that. And I want to move this down here because this commentary here is about these two things up here. So let me move this whole paragraph down to here. And Okay, so well, let's try this before we move on. Oh, it wants to run this. So let me let it run it and check to see if it worked. Yeah, of course, MPEG audio is the dominant format. Oh, you know what? I made a mistake in the previous thing here. So let me see if I can fix this. Notice that I omitted the semicolon there. Totals across all customers. Okay, so let's get out of Claude revenue percent. I'm going to stop here. This is getting to be too much. I'm going to go back into SQLite 3 and open Chinook DB again and run these two queries and see what happens. So we have this one. Okay, so it's not giving us the totals, it's just sorting them by. So we don't really know. I mean, we know Luis did more, but we don't know some details. So that's probably why it suggested this. So let's do this. Oh yeah, nice. Okay. And then it also suggested revenue percentages as a fraction of the total, but we skipped that. Okay, and then yeah, we did these already, so we're basically done with this joining business. I just wanted to show you at the end there, I just wanted to show you ad hoc what it's like working with an LLM. We're going to talk more about working with LLMs later. But that's all for now. Thanks for your attention. Bye.